Hello everyone! It's me again, Teacher Joanne. This tutorial is for statistics and probability, a subject which is intended for grade 11 senior high school students in the Philippines. For today's objectives, at the end of the lesson, the learners will be able to identify the appropriate rejection region for a given level of significance when the population variance is assumed to be known. Then the population variance is assumed to be unknown, and the central limit theorem is to be used. For today's topic, still under hypothesis testing, we have rejection region based on significance level. So to specify the probability of committing a type 1 error, we can determine the critical values which defines the rejection region or the critical region and the region of acceptance. The critical value serves as the basis for accepting or rejecting a hypothesis. For example, when alpha equals 0.05, the rejection region is 0.05 and the acceptance region is 0.95. So for the rejection region, so we have on the left side the type of test and on the right side the difference. So for one-tailed test, so the rejection region lies entirely in one end of the distribution. So it's either on the left side or on the right side. So hypothesizing a range of values. And for two-tailed test, it involves region which is split into two equal parts placed in each tail of the distribution. So the rejection region is at the right side and on the left side, and the acceptance region is at the middle. So the value of the parameter is being hypothesized. So for the formulation of null hypothesis, so we have the rejection region. So for greater than, so area of rejection is placed entirely in the right tail of the distribution. So here's how it looks like. So as you can see, we have the critical value 1.65. So that is at alpha 0.05 for one-tailed. So the rejection region is the shaded part, and the do not reject region is the white part, which has a probability of 95%. So for rejection region less than, so area of rejection is on the left tail of the distribution. So here's how it looks like. So it's just the opposite of the greater than. So same thing, the critical value is negative 1.65 since it's on the left side. So that is the region of rejection. And at the right side, that's the do not reject region, which is also 0.95 at alpha 0.05. And for not equal to, so which is two-tailed, so both tails contain equal area serving as the critical regions. So here's how it looks like. So you have alpha 0.05, so just divide that into two. That's why we have the right side and on the left side the probability of 0.025. And the critical value is positive and negative 1.96. So the do not reject region is still 95%, which is in the middle. So next we have the t-table again. So the one at the top you will see you have for one-tailed or for two-tailed test. So this indicates the significance or confidence level or the value of the alpha. And for this value, so at the leftmost we have the degrees of freedom, which is the n minus 1, so to know the degrees of freedom. So these are the critical values of t when n is less than 30 and the variance is unknown. And we have at the bottom, so you can see the z, So those are the values for z. So these are the critical values of z when our sample size is greater than or equal to 30 and the variance is known or the central limit theorem is being used. Next, we have the test statistic. So these are the decision rule for critical value method. So we have for ztest, so this is used when our sample size is greater than or equal to 30 and our variance is known or our central limit theorem is being used. And we have the ttest, so this is used when our sample size is less than 30 and the variance is unknown. So for the decision rule, it's almost the same for ztest and ttest. So if the computed value is greater than or equal to the critical value, then we reject the null hypothesis. But if the computed value is less than the critical value, then we accept the null hypothesis or we do not reject the null hypothesis. But take note, so the negative sign of the computed z or t is disregarded when comparing it to the critical value of z or t if the hypothesis is non-directional or when it is two-tailed or one-tailed which is at the left side. For example, so number 1, so z computed equals 1.48. The confidence level is 90%. So let's say it's two-tailed. And then for number 2, z computed equals 1.83, alpha is 0.05, and one-tailed. So for number 1, so the critical value of z at 90% confidence level for two-tailed is 1.645. So if we compare that to the computed value of 1.48, so the computed z is less than the critical value of z, so therefore the null hypothesis is not rejected. And for number 2, the critical value of z when alpha is 0.05 for one-tailed is 1.645. So since the computed z is 1.83 compared to 1.645, which is greater than the critical value of z, so therefore our null hypothesis is being rejected. So next examples. So t computed is 2.34, confidence level is 99%, and one-tailed sample size is 21. For number 4, t computed equals 2.58, alpha 0.05, two-tailed, and n equals 17. So the confidence level is 99%. So thus alpha is 0.01. So if we look it up on our t table, so the degrees of freedom will be 20 since we have n minus 1. So the value would be for alpha 0.01 and degrees of freedom 20, that is 2.528. So we compare that to the computed value. So since the computed t is less than the critical value, so the null hypothesis is not rejected or accepted. For number 4, so our n is 17, so our degrees of freedom will be 16. So critical value of t when alpha is 0.05 for two-tailed at degrees of freedom 16, the value is 2.120. And since the computed t is 2.58, that is greater than the critical value of t. Therefore, we rejected the null hypothesis. So example number 5, computed z equals 1.59, confidence level is 90%, one-tailed. And number 6, t computed equals 2.01, alpha equals 0.10, two-tailed, and n equals 25. So the critical value of z at 90% confidence level, or alpha at 0.1 for one-tailed, is 1.28. So if we compare that to the computed z, which is 1.59, so our computed z is greater than the critical value. So therefore, we reject the null hypothesis. And for last number, so since our sample size is 25, so we'll be looking up at degrees of freedom equals 24. So the critical value of p when alpha is 0.10 for two-tailed at degrees of freedom is 24 is 1.711. Since the computed t is 2.58, so it is greater than the critical value. So therefore, we reject the null hypothesis. Now, let us check what have we learned for today's lesson. So give the critical value using the confidence level, alpha, and or degrees of freedom, if that is for t-test, and determine the decision for each of the given computed value of the z or t. For number 1, z computed equals 1.15, confidence level equals 95%, and one-tailed. Number 2, z computed equals 2.65, alpha equals 0.01, and two-tailed. Number 3, t computed is 2.02, confidence level is 90%, two-tailed, and sample size equals 15. Number 4, t computed equals 1.67, alpha equals 0.05, one-tailed, and sample size is 27. Next, t computed is 3.18, alpha is 0.01, two-tailed, and sample size equals 10. Okay, now let us check the answers. So for number 1, alpha is 0.05. The critical value is 1.645. So the computed z is less than the critical value of z, so null hypothesis is not rejected. For number 2, alpha is 0.01. So that's for two-tailed. So critical value is 2.576. So z computed is greater than the critical value of z. So our null hypothesis is rejected. Number 3, alpha equals 0.10. So that is two-tailed. So our degrees of freedom equals 14. The critical value is 1.761. So computed t is greater than the critical value of t. So our null hypothesis is rejected. And number 4, alpha is 0.05. Degrees of freedom equals 26. So the critical value is 1.706. So t computed is less than the critical value of t. So our null hypothesis is not rejected. And for the last number, alpha equals 0.01, so two-tailed. Degrees of freedom equals 9. So the critical value is 3.25. So the computed t is less than the critical value of t. So our null hypothesis is not rejected. So I hope you got all the correct answers. And that's a great job for today's lesson. So we're done for today, and thank you very much. I hope you learned a lot and see you in our next lesson. Bye!